you're going to get some new theorems today and a postulate, a little bonus postulate. Some of these are real obvious. Look at this linear pair postulate. If two angles form a linear pair, then they're supplementary, right? Yeah, I mean, we noticed this before, right? This is a 180-degree straight angle. So, of course, these two angles are going to add up to that 180. That's the definition of supplementary. So if angle 1 and angle 2 form a linear pair, then they are supplementary. So the measure of angle 1 plus the measure of angle 2 add up to, what's that going to be, Amanda?
180 degrees.
180 degrees. So that's what goes in that blank on the bottom of page 2. What do you mean one name? Well, you know what you can do, and you know, some of you are getting frustrated. There's all these different postulates, and I can't remember. You don't have to say in a reason linear pair postulate. You could say two angles in a linear pair are supplementary as your reason. For me, that's what I do. It's easier for me to remember that that's the linear pair postulate. These ones aren't too complicated, but as we go on, a few of these theorems today, I just say what they are. I don't use their so-called name, because those names are not what everybody calls them. So I'll show you what I mean in a moment. So the right angle congruence theorem. So now we're on page 3. I mean, duh. All right angles are congruent, right? We know that. We could make it a postulate, but if we can make it a theorem, we do, so that it's proven. Real briefly, right? If you have a right angle, you want to prove two right angles that they are congruent. So give me two right angles. Okay, here they are, angle 1 and angle 2. The measure of angle 1 is 90, and the measure of angle 2 is 90. How come? What do you think, Amy? Yeah, that's what right angles are. Definition of right angles. This can lead us to say that the measure of angle 1 equals the measure of angle 2. How come, Jack?
The transitive theorem. Yeah, transitive theorem.
Well, this one, we're working with equality.
Oh, the measure.
Yeah, so that's right. Yes, transitive property of equality, right? Because they're both 90, they're both equal to each other. And then what do you think we're going to do now? Bounce that back to congruence using the definition of congruent angles. If the measures are equal, then the angles are congruent. So here we go, the right angle congruence theorem. Now I will say this, if I need to use this in a proof, I will never write right angle congruence theorem. I am not good at remembering the titles. What will I say? If I need to somehow say that two right angles are congruent, I'm just going to write all right angles are congruent. For me, that's easier. I'm not going to remember all these different names. Okay. Congruent supplements theorem. This one's slightly more complicated, but not horribly complicated. Did you have a question?
Yes, I just wondering, if I am able to memorize all these theorems, which I probably will because I have a good memory, can I use the theorem names?
Yeah. The only caution is I'm not sure that it's like a universal name that they're giving them. This is like our textbook company is giving them these names. I'm not sure if they'll know, but I'd be fine with it. I'm fine with it if you do that. Okay, so the Congruent Supplements Theorem, this one is actually maybe easier to remember the name, because it says if two angles are supplementary to the same angle, or two congruent angles, right, then they are congruent. So this says that if you have two sets of supplementary angles, angle 1 and angle 2 supplementary, angle 2 and angle 3 supplementary, 1 and 3 have to be congruent angles. Now, doesn't that kind of make sense, right? So these are supplementary, and these are supplementary. So since they're both supplementary to the same angle, they have to be equal. And we call that the congruent supplements. So angle 1 and 2 are supplements. That's our given, right? So I'm going to give you that condition. That's occurring. So that means that their angles, their measures are going to add up to 180 because that's what supplementary angles are. So the definition of supplementary angles. Okay, then I'm going to say, well, that must mean that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. How come? Yeah, how come, Jack? Substitution or transitivity, right? Either one I'll accept, right? This group is equal to 180 and 180 is equal to that group, so those things are equal. Now I'm saying that the measure of angle 1 equals the measure of angle 3. How come? Subtraction property of equality, you're subtracting the measure of angle 2 from both sides. So that is the subtraction property of equality. And I'm nearly there, right? My goal is to prove they're congruent angles. Well, if their measures are equal, then they are congruent, right? Because that's what congruence is, the definition of congruent angles. So we get there awfully quickly. Yeah?
What if you're working with, like, you have to prove equal congruence, but it's like the equal sign, like, you're supposed to, like, you're giving it to the equal sign, not congruent.
You're trying to prove two congruents are the same angle?
I mean, like, if it's, like, let's say measure of angle one, if it's, you have to prove it's equal to measure of angle two.
Then you would stop here, that's what I wanted to
So,
prove.
I mean, like, would you use a theorem, would you call it a theorem if it's equal?
Yeah, it's called a theorem if you prove a conjecture through
I
it.
mean, like, at the end, would you call it like property or a theorem? Like,
Theorem.
Like,
If you are proving something, you have done a theorem. Even if let's say this was saying prove that the measure of angle one equals like that. If that was your proving, that means I would just stop right here, and it's still a theorem, you're still proving it. Just because you have equals in it doesn't mean that it's not proven.
if it ended with tangent property, would you say tangent theorem or?
Well, it depends what you're doing. So if I'm working with equals, this one is a transitive property because I'm working with the operator of equality. If I was working with congruent angles, then I would say the transitive theorem of congruent angles. Right? I mean, it all depends on what operator you're working with. If that makes any sort of sense. The congruent complements theorem is almost the same thing except for 90-degree angles. So if you have two sets of angles that are complementary, they add up to 90 degrees. Angle 1 and 2 are complements, angle 1 and 3 are complements, then that means because we have the same angle here, 2 and 3 are congruent. And this proof is going to be pretty much the same thing. So they're complements because they're given. That means they add up to 90 degrees because that's what complementary angles are. Definition of complementary angles. So now I can set them equal because they're both equal to 90. These two pieces are equal by transitivity, transitive property of equality, right? Because I'm working with the equal sign. So I'm going to subtract the measure of angle 1 from both sides using the subtraction property of equality to get that the measure of angle 2 equals the measure of angle 3. And once I know that the measures of two angles are equal, that means they are congruent because that's the definition of congruence. If the measures are equal, then the angles are congruent. So this one, almost the same proof, except we're working with complementary instead of supplementary. Right? And let's see, I think I got one more here to prove here. Vertical angle congruence theorem. This is one that I also will never say vertical angle congruence theorem. To me, it's easier to say vertical angles are congruent. If I ever need to do that in a proof, that's what I'm going to say, because I think that's much clearer to whoever is reading the proof, and to me, it's easier to remember. Why are vertical angles congruent, right? We've talked about this. Well, why? So, huh?
Because they are.
Because they are. Well, yes. And then a miracle occurs, right? No, we have to prove it. So angle 1 and 3 are vertical. That's my given. I want to prove they're congruent, right? So there's my given statement. So let's see where we're going from here. So 1 and 2 are a linear pair, and 2 and 3 are a linear pair, because that's what linear pairs are. I can see that in the diagram. So definition of a linear pair just by looking at it. Well, that means an angle 1 and 2 are supplementary, and 2 and 3 are supplementary. That's our new postulate. The linear pair postulate states that if you have a linear pair, the angles are supplementary. So I'm using that one. And now we're going to use that brand new theorem that we just had. Look, I've got two sets of supplementary angles. They're both supplementary to angle 2. That means that angle 1 and 3 must be congruent. Because we just proved that using the Congruent Supplements Theorem. Oh. So I don't have to reprove all that again. I already did it. So I'm using a theorem that we just had. Congruent Supplements Theorem. If angles are congruent or supplementary to the same angle, then they are congruent. Okay, so wow, now we've got a whole bunch of new things that we can use. So quick review, the linear pair postulate, two angles form a linear pair, then they're supplementary. Right angle congruence theorem, all right angles are congruent. Congruent supplements and congruent complements, very similar. Two angles are supplementary to the same angle, then they're congruent. Or two two angles are complementary to the same angle, they are congruent, and vertical angles are congruent. Okay, so that's what we just did. So you have a little, again, this is on the website if you kind of want to see them all together. So let's use a quick example here, how we can use these things. So find the angle measures here. So if the measure of angle 1 is 112 degrees, find 2, 3, and 4, and then tell me what theorems and postulates we're using. So let's see, what we got here. What's the measure of angle 2 going to be? You know what's that going to be? 68 degrees, how'd you get that?
It's 180 last one.
Right, by the linear pair postulate, I know that these are supplementary angles, so that means 180 minus 112, right? The measure of angle 3, what's that going to be? Yeah, any? So what's its measure? 112, because vertical angles are congruent. Alright, and then the measure of angle 4 is going to be what? This should be not a trick question. What's the measure of angle 4? Joseph? 68. How come? Right. Either one, you can say, well, it is because there's a linear pair, so it's 68, or you can say it's vertical because I found the other one. Either one. Right? Let's see what else we got. So now when we get problems like this, it's like we're starting fresh each time. It's easy for me to erase. When I do problems like this, I'll draw a separate diagram for each one if I'm doing this on a piece of paper so that I can see what's happening. So now let's say the measure of this one is 67. What's the measure of angle 1? Measure of angle 1. Amanda?
Well, the measure of angle 1, well, that would be, since when you turn out of the 180, you have to subtract 67 from 180. So 180 minus 67 would be, yeah, that would be 113.
Good. And you know what? That was a beautiful explanation. Very nice explanation. She basically explained the linear pair postulate, right, which is what she used. What would the measure of angle 3 be then? Measure of angle 3? Yeah?
Be 113 degrees again because
Right.
of the vertical angles congruence theorem.
Absolutely, right? Vertical angles are congruent. And then the measure of angle 4, we can get that two ways. It's either using the linear pair postulate again or using vertical angles. Easy. Alrighty. And then if the measure of angle 4 is 71 degrees, right? We're just doing this over and over again, aren't we? So the measure of angle 1, we probably want to use the linear pair postulate. 180 minus 71, that's 109, isn't it? I think.
103 minus 100 what?
109, I think I got it. Linear pair postulate. Measure of angle 2 is going to be 71. Vertical angles are congruent. And the measure of angle 3, 109, either if you saw it by using the linear pair postulate or by using vertical angles. Either way. Okay, so that's a quick application of it. Okay. Look at this. Look how we're moving right along. We're on the last page already. So let's see what's going on here. I've got an example. We're looking for congruent angles here, and they're telling me angle 1 and 2 are complementary, angle 2 and 3 are complementary, so these are complementary, 2 and 3 are complementary, and 1 and 4 are complementary, plus I see a right angle box right here. So can you give me a set of congruent angles, Joseph? Angle 1 is congruent to angle 3, how come? Congruent complements theorem, right? And so basically, if you look here, you say, oh, wait, here's the 2's match. So they're complementary to the same angle, therefore they are congruent themselves. What else do we have? Anything else? Look at this here. Yeah, what else? Angle 2 and angle 4 are also going to be congruent for the same reason, because they're both complements of angle 1. 2 and 4 are going to be congruent. We've got some other ones too. Because one is congruent to 3, and 2 is congruent to 40. Are they necessarily all congruent?
Yes,
Why?
they are.
Why?
This triangle has 180 degrees.
So?
And since half of it's a right angle, the others.
I know they're complementary. Who says they're both 45? How do I know that? Why do they have to be half? What? These are all right angles, right? So you're looking for congruence. So angle 5 is congruent to angle 6, is congruent to angle 7, is congruent to angle 8. I don't think that 1 and 2 are congruent to each other. I don't think I have that evidence. Let me see what I got here. Yeah. They're complementary. They are going to add up to 90, but I don't know that they're both equal. Alright, so using these different theorems. Let's see what our next example is. Our next example is to find the value of the variables. So we're finding x and we're finding y. Okay, we've done these before, but now we're kind of using the theorems to support it. So I don't want x's and y's in an equation because then I can't solve it. So I can't really use the linear pair postulate to solve it. So I think I'll use my vertical angles. So 3x plus 7 equals 4x minus 18 because vertical angles are congruent. I can also set up the other one, 7y equals 5y plus 28. Same reason, vertical angles are congruent. And now I can solve this. So x equals 25. I'll use the symmetric properties as well using that thing around. This one becomes 2y equals 28. Looks like y is 14. Get those. So now we've done this before, but now we're applying postulates and theorems, saying why we can do it. Yeah?
Yeah.
You got it?
Well,
We're still writing them down, but it makes sense, right? Nothing all that new here.
This is good. You don't have to write down the long lines and back up.
We don't have to do what?
Write those long lines and back up.
Well, I'm giving you a break, aren't I? But I hope you're thinking it now. Is anybody kind of thinking it a little bit?
Yeah.
Yeah, good. Thinking like a mathematician. I like it. All right, example 4. We got a little proof here. So let's see what we know here. We know that angle S is a right angle. We know that the measure of RTS is 40. And we know the measure of RTU is 50. And we want to prove that angle S is the same as STU. Now, we can see it, right? I mean, this one is 90, this is 40, this is 50, that one's 90. So I believe it. Let's see if we can fill in the proofs and, write this in a real structured way. So angle S is a right angle, right? These are my givens. There's all my givens. So now I've got something equals the measure of RTS plus the measure of RTU. RTS plus RTU. Which one's that one going to be?
Measure of angle RTS plus measure of angle RTU equals 90 degrees because of the angle addition postulate.
Let me see. I don't know if I was going there quite yet. You're absolutely right. That's the problem with these proofs. If you wrote a proof from scratch like that, you'd be correct. I think this one was we're breaking it down a little bit further. It's not that you're incorrect, you are correct. This one should say the measure of angle STU. It's just what we were looking for by the angle addition postulate. So what they're doing here is they broke it down a little bit further than you did. You're not incorrect. Let me just put it that way. So this measure is the measure of these two by the angle addition postulate, and then we're going to use the substitution property to put in the 40 degrees and the 50 degrees. So it's just broken a little bit more. It's actually okay the way we did it. I'm going to add those together. So the measure of angle STU is 90 degrees. So that means that STU is a right angle because that's what right angles are, the definition of right angle. Because it's, if its measure is 90 degrees, it is a right angle. That's the definition. And now I'm going to say that something's congruent by the right angle congruence theorem. And again, I have to write that out. All right angles are congruent. That's what that is. So what are we trying to make match up here? We're trying to say that angle S and STU are going to be congruent because this one's a right angle and this one's a right angle. And if two things are right angles, they are congruent. That's the all right angles are congruent theorem. Yes?
Does an angle with a measure of 270 degrees give a special name?
Nope. None that I know of. Alrighty, let's picnic table. So, you know, you're looking at it sideways, right? These are the benches, there's the tabletop, you would be sitting here, right? So I'm looking at a picnic table. Angle 1 congruent to angle 4, and I want to prove that 2 and 3 are congruent. Alrighty, so I think we know the first one, right? That's my given. So angle 1 and something else are a linear pair, and angle 3 and something else are a linear pair. Now, which one is Joseph? Angle 1 and angle 2, yeah, and angle 3 and angle 4. And why? Because they look it, right? You know, in its definition of a linear pair, you could say given even. I would be okay, because it is. It's given in the diagram that they are, just by looking at them. So then what do I know? By the linear pair postulate, what can I say about angle 1 and angle 2? They're a linear pair, so the linear postulate says, Amy, that they are supplementary. So now I can just say that angle 1 and 2 are supplementary, and angle 3 and angle 4 are supplementary, because that's a linear pair postulate. Form a linear pair, you are supplementary. Now somehow we got here. I'm going to insert a 3A, make it a little bit easier to see it.
Oh, that was part of the theorem.
It's what part of the theorem?
How they jump together.
Well, how did I get here? Well, how did we get here?
Since one and 4 are congruent, it's like being supplementary to the same idea.
Right. So I can change this to say angle 4 and angle 2 are supplementary by substitution, right? This one. Just changing that because they're equal, congruent. I'm using substitution here. So now maybe we can see it better. Because these two things are the same, and these two angles are supplementary, both supplementary to angle 4, then angle 2 and angle 3 are going to be congruent using the Congruent Supplements Theorem. So they sort of skipped a step. They're making a little bit of a leap there. So if you're having trouble seeing it, all they did was they substituted angle 4 in here. And now I can see I have a match. So these two are going to be congruent. Maybe? Alright, questions on that one? It was a little bit trickier. These are you tries. Honestly, take a second to just do this one if you haven't. How are we doing with this U try? Because they are vertical angles, did we set them equal? Did we solve the equation? Do we remember to plug it back in? Did we just stop here? We went back and said, oh wait, they didn't ask for x. We said find the measure of AEB. AEB is 4x minus 18. By substitution, I'm putting in that 22, and I did that computation. Did you get 70 as well? Yeah?
I got 70 degrees.
70, well, you're correct. You're more correct than I am, 70 degrees. How about this proof here? You may or may not have started this. Let's just take a look here. What do they want us to do? Angle 4 is a right angle is my given, which we know means all of them are right, because we can use that linear pair postulate all the way around. We want to show that 2 and 4 are supplementary. So it's starting with the given. And then it says definition of a right angle. So that means what? That the measure of angle 4 is 90. That is the definition, 90 degrees, is definition of a right angle. So saying that, yes? Okay, well angle 2 is congruent to angle 4, how come? Yeah, the vertical angles are congruent. I'm always going to write that one out. Vertical angles are congruent. Anytime I don't have to memorize it now. I'm good with it. Okay, and then my reason here is definition of congruent angles. What is the definition of congruent angles? If two angles are congruent, then what? Yeah, their measures are equal. So I'm going to make the measure of angle 2 equal the measure of angle 4. So far, so good. And then it says the measure of angle 2 is 90. How come? Yeah, Keely? Transitive property? Let's see, because the measure of angle 4 is 90, and the measure of angle 4 equals the measure of angle 2, that means that measure of angle 2 is 90, yep. Transitive property of equality. Because I'm working with equals. And then what? Measure of angle 2 plus the measure of angle 4 equals 180. Yeah? Angle addition postulate, let's see. Am I adding two adjacent angles to get the whole thing? No. Let's see, where's that coming from? Yeah, do you know, Ollie? You're looking for that congruent complements? I don't see two sets being said congruent here. What's going on here? The measure of angle 2 is 90. The measure of angle 4 is 90. It's kind of like they sort of put two steps together here. I believe they're substituting. They substituted in the 90s to get that 180. And then because they are add up to 180, that must be that they're supplementary by the definition of what supplementary is. Question?
For the second one, I put addition property of equality because on the right side they added 90 degrees, and on the left they added negative angle 4, which is equal to 90.
So you're saying they added 90 to both sides. Interesting. Okay, all right, you've explained it, okay. I didn't see it that way, okay, that works for me. Any other questions? Awesome.